Welcome back to another Daishinfinity video. In this video, we're going to prove the so-called binomial coefficient, which states that n choose k is equal to n choose n minus k, which is also equal to n minus k choose k, plus n minus 1, n minus 1 choose k plus n minus 1 choose k minus 1. So let's dive right in and prove this formula. So what is n choose k? So n choose k is comes from combinatorics. It states that it describes the amount of combinations you can take out of n elements. How many k elements you can actually take. So it is actually defined as n faculty divided by k times n minus k faculty. I'm not really sure how the Fakultät really is in English, but I hope I'm actually right about it. I'm sorry, I just remembered myself. It's factorial. So let's just use the word factorial to describe this. Now the first equivalence states that n choose k is equal to n choose n minus k. So let's just dive right in and prove this formula. We know that n choose k is n factorial divided by k factorial times n minus k factorial. This should be equal to n factorial divided by n minus k factorial times n minus k factorial. Now what is n minus parentheses n minus k? This is obviously n minus n plus k. So the n's will cancel out and we will have the same thing. So we see that n choose k is equal to n choose n minus k. Okay, that is actually pretty obvious. Now let's try and prove the other equivalence, stating that n choose k is actually equal to n minus 1 choose k plus n minus 1 choose k minus 1. Now let's use this and get to this. Because if we get to this, we know that this is also equal to this. So what is actually n minus 1 choose k plus n minus 1 choose k minus 1? Now n minus 1 choose k, as definition goes, is actually equal to n minus 1 factorial. So you take the upper one factorial divided by the lower one factorial multiplied by the upper one minus the lower one factorial. Now the same thing we'll actually do over here. So we will have a k minus 1 factorial times n minus 1 minus, oh, I'm sorry. What just happened? I'm sorry about it. n minus 1 minus k minus 1 factorial. Now what is n minus 1 minus k minus 1? This is equal to n minus 1 minus k plus 1. So we see that minus 1 and plus 1 now cancels out. And now we can actually say that this is equal to n minus 1 factorial divided by k factorial times n minus 1 minus k factorial plus n minus 1 factorial divided by k minus 1 factorial times n minus k factorial. Now, in order to put the fractions together, we need to have the same denominator. And we actually see that k factorial is almost similar to k minus 1 factorial. So what should we actually do to get k factorial from k minus 1 factorial? Obviously, we can see that k factorial is actually k times k minus 1 factorial. And over here, let's take another color. We see that n minus k is actually n minus k times n minus k minus 1 factorial, which is actually the same thing as n minus 1 minus k. I just flipped those two with the commutative rule. So what should we actually do? We want to get to m minus k factorial and k factorial. So we actually have to multiply this fraction by n minus k in order to get n minus k factorial, and this fraction by k to get k factorial. So what we will actually get is n minus 1 factorial times n minus k divided by k factorial times n minus 1 minus k factorial times n minus k, which is actually equal to n minus k factorial, plus n minus 1 factorial times k divided by k factorial. So we don't need any parentheses, since k times k minus 1 factorial is actually equal to k factorial and n minus k factorial, as it was already in the previous one. Since now we have the same denominator, we can actually say this is equal to n minus 1 factorial times n minus k plus n minus 1 factorial times k, all divided by k factorial times n minus k factorial. Now if we actually take the n minus 1 out of it, then we say that n minus 1 factorial times n minus k plus k is actually equal to the previous numerator divided by k factorial times n minus k factorial. Now what is n minus k plus k? It's actually n. So what is n times n minus 1 factorial? It's actually n factorial. So now we got n factorial divided by k factorial times n minus k factorial, which is actually n choose k. So now we have proven that n choose k is equal to n minus 1 choose k plus n minus 1 choose k minus 1. So I hope you guys enjoyed this video. Please like and subscribe, and we'll see us in the next Daishinfinity video. See ya.